sometimes we're given quadratic functions like this in standard form, and we're interested in getting them into vertex form. How can we do that? Well, there's a process that we have called completing the square, and it goes like this. Provided that the coefficient of the x squared term is 1, we look over to the coefficient in front of our x term. We take this number, we divide it in half, and we square it. And we're going to add that new term that we've created to our expression. So I'm going to add b over 2 squared, like this. b over 2 squared is going to be some number. Since I've added this number to the function, I also must subtract it from the function as well. So I'm going to show that here in red. I'm going to subtract b over 2 squared as well. Now what happens is these first three terms here are a perfect square trinomial. So we can factor these ones, x plus b over 2 all squared. And then we have this leftover term, plus c minus b over 2 squared. And we see now that we have vertex form. We have x plus h squared plus some other number here that we usually call k. Let's look at the example f of x equals x squared plus 6x minus 7. We're going to try to complete the square with this function to try to find the vertex of this parabola. So remember, our first step is to check and make sure that we have a coefficient of 1 in front of our x squared. In this case, we're okay with that. So we move over to the coefficient in front of the x term, which is 6. We take that 6, we divide by 2, and then we square it. 6 divided by 2 is 3, and when we square it, we get 9. So 9 is going to be the value that we need to add and subtract from our function in order to complete the square. So I've indicated those changes here, our addition in blue and our subtraction in red. Now we can go ahead and factor our first three terms into a perfect square. So we're going to get x plus 3 all squared. Now what you can do here is you can expand this out and double check that you do indeed get this trinomial. After you've factored those first three terms, then you can go ahead and add together the constants over at the back here. So we have negative 7 minus 9. That is going to be negative 16. So now we have vertex form of our parabola, and we can find the vertex. The vertex is going to be given as negative 3, negative 16. I think it's worthwhile here just to pause for a moment and explain to you geometrically the process that we're going through for completing the square. Now, geometrically, we're only going to be focusing on these two pieces here, the x squared and the 6x. Let's think of the first piece, which we're going to call x squared, as a square with side lengths x and x. The second piece, which is 6 times x, we're going to think of as a rectangle with side lengths 6 and x. Now what we could do is we could divide this 6x that we have in half to get two pieces that are of size 3x. After we've made this division up here into two equal sizes of 3x, we could actually attach them right against our x squared piece like this. And then you might be able to see that down here in this corner, if we were able to figure out the size of this square, we could complete the bigger square. Now what is the size of this little square down here? Well, it has side length 3 here and side length 3 here. So the area of this square is 3 times 3, or 3 squared. And this is exactly the term that we add in when we're trying to complete the square algebraically. So this is where these steps are coming from. First, we take our 6 and divide by 2 to get 3. That's going to give us the side length of the new square that we need to create. And then in order to make a square, we're going to multiply both of our sides together. Or what we do is we take this value of 3 and we square it to get 9. And this is the value that we're going to be adding and subtracting to our quadratic equation. So hopefully that gives you an indication of why we do the procedure the way that we do. Let's take a look at a more challenging example of completing the square, one where the coefficient in front of our x squared term is not equal to 1. In these cases, the first thing you want to do is group together your terms that have an x in it and factor out whatever number is in front of the x squared. So in this case, I'm going to factor out a 5 from the x squared and from the negative 4x. So here I'm going to get negative 4 by 5 x's. I'm not going to factor out a 5 from the negative 2 because in this step, in this procedure, it's not really necessary to do so. Now that we have a coefficient of 1 in front of the x squared term, we can work through our procedure. We're going to take this value of negative 4 over 5, we're going to divide by 2, and whatever we get from doing this, we're going to square. Because we're working with fractions here, it's probably easiest if we write the division sign using the division symbol, and then we flip and multiply. So, after division by 2, we're going to get negative 4 over 5. This is really the same thing as multiplying by 1/2. And we should get negative 4 over 10. Or we're just going to simplify this to negative 2 over 5. Remember, we still have to square after our division by 2, so we're going to get negative 2 over 5 squared, and this is the same thing as 4 over 25. Now that we know the value that we have to add and subtract, 4 over 25, I've gone ahead and I've put that in here. Because this example had a coefficient of 5 in front of the x squared, we can't put the 4 over 25 inside the brackets and then the negative 4 over 25 outside the brackets, otherwise things will not be balanced properly. So here I've put them both inside of the brackets. And our goal now is to get rid of this one. We have to somehow get this one outside of the brackets so we can group it with this minus 2. So to do this, what we can do is distribute the 5 only to the negative 4 over 25. And we'll leave everything else the same. So we're going to get something that looks like this. We're going to have 5 bracket x squared minus our 4 over 5x plus the 4 over 25 that we need in order to complete the square. And if we distribute the 5 through, we're going to get negative 5 times 4 over 25 minus 2. So that's how we remove the negative 4 over 25 out of the brackets. So I've gone ahead and I've multiplied these two together to get negative 4 over 5, and I've factored our original bracket to get x minus 2 over 5 all squared. Our last step is just to collect all of our terms over here on the right-hand side. Now 2 is 10 over 5, so we have 4 over 5 minus 10 more. That's going to give us negative 14 over 5 as our constant here. And this tells us that the vertex must be 2 over 5, comma, negative 14 over 5. All right, my little epsilons, stay positive.